Today, we will learn how to create and use multiple regression in RStudio using the iris dataset. Multiple regression is when two or more independent variables are tested with a single dependent variable to see if there is a linear correlation, or line of best fit, between the variables. However, you cannot test two dependent variables with a single independent variable, because linear regressions cannot exist with more than one dependent variable. To create the multiple regression, we will follow a similar process as to simple linear regression, with a minor tweak. So, as you may recall from our previous video on linear regression, we will write regression 1 equals LM, in parentheses, your dependent variable, mine will be sepal underscore length, then tilde, your independent variables. So mine will be sepal underscore width plus petal underscore length. As I explained in my linear regression video, the tilde expresses that the variable before it depends on the variable after it. So, the variable before it is the dependent variable, and the independent variable is after it. To find the p-value, which I covered in a previous video, we will write summary, in parentheses, regression 1. Now, when you run both lines, we will see that the p-value of the sepal underscore width and petal underscore length are both significantly lower than 0.05. They are right here and right here. So, we know that the variables have a significant linear correlation and linear regression will be effective. However, if you watch my video on linear regressions, you may be a bit confused about how sepal underscore width has a much lower p-value than in a single regression. In case you haven't seen that video, let us create the linear regression between sepal underscore width and sepal underscore length. So, we will write regression 2 equals LM, in parentheses, sepal underscore length tilde sepal underscore width. Then, on the next line, write summary, in parentheses, regression 2. Now, when we run both lines of code, you will see that the number for the p-value of sepal underscore width is much higher, 0.152. In fact, it is higher than 0.05. So the two variables do not have a significant linear relationship, which is completely different than in the multiple regression. This can be explained because of the relationship between the two independent variables. If we create a regression between sepal underscore width and petal underscore length, we will see that the p-value is very small, and is thus the relationship is significant between the two variables. So, let's do that. Regression 3 equals LM, in parentheses, sepal underscore width tilde petal underscore length. So now we have both of our independent variables in our regression. Now let's write summary, in parentheses, regression 3. And once you run both lines of code, you will see that the p-value for petal underscore length is significantly lower than 0.05. So that means that sepal underscore width and petal underscore length have a significant linear correlation with each other. So, in the multiple regression, the p-value will be much smaller than in the single linear regression, because there is a significant relationship between the two independent variables, and thus a more significant relationship in the multiple regression as a whole. So, we now know how to create a multiple regression and the reason why the p-value of the same variable can change in a single and multiple linear regression. Thank you for watching. Please like, share, and subscribe.